Hello students, today we are going to see how to test the hypothesis, the procedure for testing the hypothesis. In the last class, I have told you what is null hypothesis, alternate hypothesis, and what is alpha significance level, and based on alpha you have to decide whether it is one tail test or two tail test, and then you have to draw the graph. So yesterday when I told this, I told these are the two steps which you have to write for any problem. So now we go for the general procedure. I am giving you a general procedure how to test the hypothesis. So these 6 steps what I give you now, I have written the 6 steps. These 6 steps will be used for any type of problem in the hypothesis testing. So this is the general procedure. So for any hypothesis testing we follow only this procedure, but there will be a slight difference in the formulas, but the 6 steps are the same. So first thing is, this is a procedure for hypothesis testing. The first thing is you have to state the null hypothesis. That is, when a problem is given, first you have to write what is the null hypothesis. That is, yesterday I already told you, h naught mu equal to whatever average value or whatever mean value they give you, you have to mention here. Then we will check whether that particular value is right or wrong. We are doing all this problem only to check this null hypothesis which you have assumed. I already said null hypothesis is a assumption which we wish to test. So we will be testing for this mean value. So mean, whatever mean value is there, whatever you write here, our aim is to check that particular value. So the first thing is you have to write the null hypothesis, that is h naught mu equal to whatever value is there, you have to write that. And next, immediately I told you, once this null hypothesis is wrong, you have to accept something else. So you cannot leave the problem. So suppose this is wrong, you have to accept alternate hypothesis. So I told you yesterday itself, alternate hypothesis will be one among these. Either only one for any problem. Either it will be not equal to or less than or greater than, any one particular value. Only one option you have for alternate hypothesis. You can't write all the 3. Look at the problem and mention what is the alternate hypothesis. It will be one among these, either not equal to or less than or greater than. So first null hypothesis, second step is alternate hypothesis, and next in the problem itself you will be given alpha. You have to write that particular value alpha, and based upon this alternate hypothesis you have to decide whether it is one tail or two tail test. If it is not equal to, it will be two tail test. If it is less than or greater than, it will be one tail test. So once you write the alternate hypothesis, mention, beside that only you have to mention whether it is one tail or two tail, and write the value of alpha. And next step, in the third step, based upon this one tail or two tail, you have to plot the graph. So it will be like this. If it is normal distribution or t distribution, we have to decide based upon the number of samples, and you have to draw the graph. So after you draw the graph, if it is two tail, we have two rejection regions like this. If it is one tail, it will be to one end, this side or left side or right side. So next is you have to find z. If it is big sample, we find from the normal distribution table z. If it is small sample, we take the t table and find the t value. So that particular value will be this value, this particular border value. So this is z equal to, or if it is small sample, t equal to. You will find this from the graph. So first thing, you will find z or t based upon the sample size and find that and put it in the graph. Next step is, fourth step, you have to calculate standard error of sample statistic. That is, with the help of standard error, sigma x bar is sigma by root n. Sigma is the standard deviation divided by root of n is the sample size. Find this sigma x bar, and in the next step we find our calculated z value. This z or t will be from the table. This is from the values what they have given from the problem. So it is Z will be x bar minus mu h naught by sigma x bar. X bar is the sample mean, mu h naught is the assumed mean, what you have assumed here, the divided by this sigma x bar. So whatever value you get here Z, based upon this Z, you will decide whether to accept or reject the null hypothesis. So the last step will be our decision. So our decision, suppose from the table I got Z equal to, for example, 1.7 something. So this Z, I got this value as 0.7. So this 0.7, and already we have got from the table 1.7. Based upon this you have to decide. So this is 1.7, 0.7 will be somewhere here. It comes into the acceptance region. This is, yesterday I told you, this is the rejection region. So if it comes in the acceptance region, what value you have calculated, then we accept the null hypothesis. Suppose I got this value as 2.7. If it is 2.7, it is greater than 1.7, so it falls in the rejection region. So you reject. If it falls in the rejection region, whatever value you find the Z value, if it is in the rejection region, you reject the null hypothesis. If it falls in the acceptance region, then you accept the null hypothesis. So that is our final decision. So these 6 steps are very, very important. Based upon this only you will do the problem. Okay, this is a table which mentions which distribution you have to use when the values, what values are given, based upon the values, which distribution you have to use. When n is greater than 30, that is, it is a big sample, you remember this. When n is greater than 30, it is big sample, then you have to use normal distribution. If n is less than or equal to 30, it is a small sample, then we use t distribution. So this t distribution also you can use when two conditions satisfy. Already I have said. So that is when it is less than or equal to 30 and when population standard deviation is not given. In these two cases only you can use t distribution. But if n is greater, that is if it is big sample and population standard deviation is given, we use Z. And if it is not given also, whatever you have for the sample you can take it and you can use Z only. And if it is small sample and population standard deviation is given, then also it is Z. You can use T table only when your sample size is small and when population standard deviation is not given. So only in these two cases you use T distribution. So you remember this, and then in the next class we'll go through the problem, that is based upon these 6 steps when a problem is given, how to work. That I'll tell you in the next class.